Hello students, welcome to Vyas Certification Kota. In this series of NCERT discussion, time to continue further with Mathematics class 11th, and today we'll be dealing with miscellaneous exercise of binomial theorem. Yes, the very important miscellaneous exercise will have questions from all the topics covered in the chapter. Not only that, some more questions which develop your thinking further. Some difficult questions will also be included over here which are not covered in the previous exercises, right? So let's begin with each of these questions over here. Let's begin with the first one. Remember, you are also supposed to attempt all the examples from this exercise related to this exercise as well, so that you get a better idea of the questions over here, and you can solve the questions in the examination, any kind of examination that you have upcoming in front of you, right? So continue further with the first question that we have. What does the question say? Which says that find a, b and n in the expansion of a plus b whole power n if the first three terms of the expansion are this, this and this respectively. So we're supposed to find a, b and n. There are three unknowns and there are three conditions, right? Let's use those conditions to solve this question. A, b and n in the expansion of this. First three terms on the expansion, right? So a plus b whole power n, what do you think will be the first term? The first term will be nc0 a power n, okay, b power 0, plus nc1 a power n minus 1 b. This is what you have. The next term will be nc2 a power n minus 2 times b square plus dot dot dot. This is what you have, right? And since it is given that the first three terms are known, let's write nc0 a power n will be equal to 7 to 9. And this gives me nc0 is 1. This will tell me that a power n is equal to 7 to 9. That's the first condition. Can we find the value of either a or n from here? I think it will be difficult. This can be written as 9 power 3, or this can be written as 3 power 6. This can be written as root 3 power 12 as well, or something else maybe, right? So we are supposed to have another equation related to a and n maybe. Then the second term says nc1 a power n minus 1 b is equal to 7290. nc1 is what we have. nc1. Let's focus on this. nc1 a power n minus 1 b is equal to 7290. Okay, not 2790. This is 7290. Okay, let's simplify this. This is n is okay. This is n times a power n minus 1. Okay, times n times b is equal to 7290, which is the second equation that you have. Okay, this is the second equation. N times a power n minus 1 times b is 7290. The next equation is nc2 a power n minus 2 b square is given to be 30375. What does this imply? This implies that nc2 is n minus 1 by 2 times 1 times a power n minus 2 times b square is equal to what? This times b square will be equal to 30375. This is the third equation. Right? These are the three equations. And how do we go about solving these equations? Okay, let's see the approach of solving these equations one by one. So in this you have n, a and b. In this you have n, a and b. In this you only have a for that matter. One of the approaches which comes to the mind is that if possible, can you eliminate b from these and maybe get another equation in terms of a and n? You may, but do you also realize that this a power n is pretty complicated? Yes. So instead of going in that direction, maybe we can go in another direction. And think in other terms. Let's divide these two. And see what we get over here. Okay. On dividing 3 by 2. Let's divide 3 upon 2. What does that give us? This gives me, let's try to simplify in this manner, n times n minus 1 by 2 times, this is a power n upon a power 2, and then you have a b power 2 already over here. This is the left hand side. What about the denominator? Denominator of 2 will be a power n over a. Then you have a n and you have a b also over here. This is equal to what? This is equal to 30375 over 7290. This is what I get, right? This is what I have. Is that okay? Yes. And when I simplify this, what do I get? A power n will get cancelled. B and A will also get cancelled. What remains is this n goes, this A power n also goes, this B square goes, this A square goes, A remains, B n minus 1 by 2A. This remains, right? Which is equal to that expression over here. What is this expression? This is 30375 upon 7290. Will it get cancelled? 7290 and this. It may get cancelled, but what do we have over here? Let's see. 30375 and 7290. You have a multiple. You have a factor of 5. You also have a factor of 3 as well, right? So we can cancel a factor of 15 directly. Let's cancel a factor of 15 over here in the numerator and denominator. 15 times 2 is 30. Then 0, then 2 and 5. This is what I get over here. This 2, 0, 2 and 75 will be 5 times, right? And 15 times what you get over here is 4 is 60, 129, 8 times is 120 and 90 will be 6 times. 486 is what I'm getting over here. And this again goes with 3, yes. This again goes with 9 for that matter, right? So let's cancel a factor of 9 once again. This will become 9 times 2 is 18 and 9 times 2 is 18 and 9 times 5 is this, and this goes 9 times 5 is 45 and 36, 54 is what you get. Okay, and you may observe that again you can cancel a factor of 9, yes. So 9 times 6 is this and 9 times what? 9 times, can you observe that? This is 9 to 25. 25 by 6 is what I'm getting over here. This is 25 by 6. Okay? Is that okay? Yes. This is 25 by 6. And what else? What else? So what I observe from this is that this 2 can go over here. That will become 50 upon 6. And that will be simplified to, let us say, 50, or we can say that this will be 25 upon 3. Right? You can cancel this 2 and this will be 3 over here. This becomes Bn upon A minus B upon A is equal to 25 over 3 is what I'm getting. You may observe this is what I'm getting. Okay. This was 3 divided by 2. Okay. You can also divide 2 and 1, and what does that give us? 2 divided by 1. Now this will be simpler probably. That's what I can see over here. This is A power n minus 1 times n times B over A power n, simply A power n. This is equal to 7290 over 729. Okay. And if you may observe, this is simply A in the denominator. This gives me NB upon A is equal to 10. This gives me NB upon A equal to 10 means this and this. This gives me NB upon A is equal to 10. This is equation number, let's call this equation number 1, 2, 3. Let's call this 4 and let's call this equation number 5. Okay. We have equations 4 and 5 now. Using 4 and 5, from 4 and 5, we see that NB by A is 10. Let's use that 10 over here. Let's use that 10 over here. 10 minus B by A is equal to 25 by 3, and this gives me B upon A is equal to 10 minus this 25 by 3, right? This will be 30 minus 25, which is 5 by 3. This becomes 5 by 3. Okay. B by A becomes 5 by 3. This is another equation once again. This is not the value of B or A. This is another equation. Let's call the 6th equation. Okay. So many equations are obtained. When will we get the values of N, A and B? We are almost there. How? You observe this is B upon A. This is also B upon A. And using 5 and 6. Using 5 and 6 will give us N will be equal to N times B by A is 5 by 3 is equal to 10, which gives me N equals 30 by 5, which is 6. This is what you get. You get the value of N from here. Once you get the value of N, therefore, use the original equation. Original equation, yes, this is the original equation. We were not aware of the values of either A or N, but now we are aware of the value of N. So once we are aware of the value of N, we can use this to get the value of A very easily. So let's get the value of A after this. From there, I'm continuing over here. Therefore, in equation 1, we get a power 6 is equal to 729, and 729 is 3 power 6. 729 is same as 3 power 6. This gives me a equals 3. We obtained n equal to 6. On the basis of this, a is equal to 3. And do you observe equation number 6? Yes. Can you get the value of a from there? Sorry, can you get the value of b from there? Therefore, equation 6 implies b will be equal to b upon a. B upon 3 will be 5 upon 3, which implies b equals 5. And yes, that's the answer for this question. The value of n, as you may observe, is 6. The value of a is 3. The value of b is 5. And that is what we were supposed to find. So calculations, yes, there are a lot of calculations. Equations 1, 2 and 3 were supposed to be formed. First of all, these are given. On the basis of this, we get simplified equations, right? We get simplified equations and then we get the values of a, b and n. Could we have moved in any other direction? Yes, there's another possibility. We could have moved and maybe we could have used this a power n over here, although we would have obtained similar equations for that matter. Similar equations? Yes, similar equations, not very different equations over here. But that's all for this question, as you may see over here. Answers, once again, n equals 6, a equals 3, b equals 5. That's all for this question.